Hello, algebra students. Welcome back to another video. This is on the second part of chapter 2.1, or section 2.1. So, same as usual, pause the video, try these problems in your notes, and unpause them to do them with me. So, write the sentence as an inequality. So convert this from English words into math speak. So, a number B is fewer means less than 30.4. Woohoo! Wonderful. B is less than or fewer than 30.4. The end. Okay. Now, tell whether -6 is a solution to the inequality C plus 4 is less than -1. Well, let's find out. If C is -6, does that work out? So -6 plus 4 is -2. Is -2 less than -1? -2 is smaller than -1 because it is more negative, so yes. Yes. -2 is a solution. Wonderful. Beautiful. Fantastic. All right, so that's what we did yesterday. Now what are we doing today? We are doing part 2 of section 2.1. So our learning target is what the graph of an inequality looks like. So we're going to do some graphing today. The success criteria is that you can graph inequalities and write inequalities from graphs. So you're going to go from a graph to an inequality, and then you're going to go from an inequality to a graph. So you need to be able to go between these two seamlessly. So I'm going to show you how to do both. Take an inequality, write a graph. Take a graph, write an inequality. Okay, so first, some vocab. What is the graph of an inequality? We're supposed to do that today, but what is it? What does it mean? So, the graph of an inequality is a graph that shows the solution set of an inequality on a number line. So anytime we graph inequalities, there is going to be a number line involved. I want you to associate those two together. So here's an example. Inequality, number line. Inequality, number line. Inequality, number line. Associate those two together. Anytime you're graphing an inequality, you're going to have a number line. Okay, wonderful. So, important information. The graph of inequality shows the solution set of the inequality on a number line. We learned that in our definition. But now, an open circle is used when a number is not a solution. A closed circle is used when a number is a solution. An arrow to the left or right shows the graph continues in that direction. So, this might be confusing. An open circle is used when a number is not a solution. So we have to check every number to know whether we should put a circle. No. So what this means is that when you have like less than or greater than or less than, you're going to use an open circle. But if you have greater than or equal to or less than or equal to, it's the or equals that makes this a closed circle. So we call this an open circle, and we call this a closed circle. So when it says a closed circle is used when a number is a solution, it's because we have greater than or equal to. That or equal to guarantees that your last number will be a solution. And if that's confusing right now, don't worry, I'm going to show you more in our first example. So it says example 3 because we're continuing 2.1 from yesterday, or from last video, excuse me. So last video we did examples 1 and 2, and now we're doing example 3. So first, we're going to look at A. It's telling us to graph each inequality. Remember, graph inequality means a number line. So that is not very line-like, huh? So we're going to create a number line. Now, don't worry, your number line doesn't need to have every single number on it. But here's what I recommend. Always put 0 on your number line. Always. And then, this number over here, we have y is less than or equal to -3. I call this number the number we care about. It is the most interesting number to us. It is the only number that we're given in our inequality. So -3 also needs to be on our number line. If you want to fill it in, you're like, no, I need all the numbers on here. You may, but when we get numbers or inequalities like x is greater than 18, you're going to have a lot of numbers to fill between 0 and 18. So I recommend just put those two on the number line, and then you don't need to fill in all of the numbers in between it. We get what you mean. Okay, so in fact, I don't even need these numbers here. I can just leave it like this, because I know that there are numbers in between 0 and 3. There's a million. There's infinitely many numbers between 0 and -3. So, what we're going to do now, we have the number that we care about, the number that is interesting to us. So, next, I'm going to put a circle on -3. And I have to decide, is it open or is it closed? The way that I decide that, which we kind of talked about earlier, is the symbol that is in between y and the number we care about. We have y is less than or equal to. Remember, when you have or equal to, you use a closed circle. When you have, we call it strictly greater than or strictly less than. We say strictly because it doesn't have the line underneath it. Then you use an open circle. So because this symbol is one of these, we're going to do a closed circle on -3. Okay, and the last thing we need to do, we are almost done, because remember in the example, we saw this blue line right here. We saw a circle, and then we saw a blue arrow sticking off in this direction. So the last thing we need to do is decide which direction is our arrow going to point in. Are we going to point this way, or are we going to point that way? What are we going to do? And the way that we do that is we're going to look really closely at our inequality right here. Y is less than or equal to -3. So if it's less than, which direction should this arrow point in? Now I don't want you to get caught in, oh, it says less than or equal to. That means the arrow points that way. Don't think of it like that. Because what if I wrote -3 is greater than y? These are the same thing, but which way does your arrow point? So do not, please do not think, oh, the inequality points that way, so my arrow's going to point that way. No, not necessarily. That might happen a large amount of the time, but it does not always happen. So please don't do that. Instead, what I'd like you to do is say, what are some numbers that are less than or equal to -3? Well, -5 is less than -3 because it's more negative. -10 is less than or equal to -3. So, all of these numbers, the more negative numbers, are going to be down here, where they are more negative. So that means that my arrow should point towards the numbers that are less than -3. The numbers that are less than -3 are the numbers that are more negative. So your arrow should point that way. Now, it does point in the same direction as your inequality sign, but again, it does not always. Okay. So, if that was a little bit confusing, don't worry, it was just our first example. We've got some more for you. So, let's look at B. And excuse me, let's recap over here. We know we are done because we have our circle. We have the circle above the number that we care about, and we have a dark, bold arrow pointing one way. You don't want to just, when you make a number line and you have your circle, you don't want to just do one arrow, because it's hard to tell. If I look at this, it's hard to tell, wait, which way? There's arrows on both sides, so which one is the solution set to this inequality? In this example, that is a big, bold arrow. You know it's pointing that way. So make your arrows very distinguishable, very dark and very big, so that I know you're pointing this way or I know you're pointing that way. Okay. All right, so with all of that, let's look at B now. So I'm going to draw us a new number line. We need to put 0 on that number line, and we need to put the number that we care about on that number line. Remember, the number we care about is the number in our inequality, and that is 2. So 2 is to the right of 0, and that's all that matters, really. You can keep your number line like this. You don't need 1,000 numbers on this number line. You can keep it right like this if you want. I do not mind. If your teacher minds, do what your teacher says, but this is how I like it. I know that 1 is in between 0 and 2. Doesn't matter. Okay, so now we need to put a circle on 2 on the number we care about. Now, remember, because this symbol does not have a line underneath it, it just looks like this, I leave the circle open. And in fact, let's write that up here. For the open, we have greater than, or less than, and for the closed, we have greater than or equal to, or less than or equal to. So because this symbol looks like one of these, we're going to leave this circle open, and we're not coloring it in. Okay. All right. Now we need to decide which direction does the arrow point in. Are we going to point that way, or are we going to point that way? You don't necessarily need to pause the video, but I want you to think, which direction right now do you think it points in? Think about that in your head. And now let's test. So we have 2 is smaller than a number. 2 is less than a number. So 2 is less than what? What is 2 less than? 2 is less than 10. 2 is less than 5. 2 is less than 813. 2 is less than all of these things. I'm going to point towards these numbers, because these numbers are solutions to this inequality. And that's what the graph of my inequality is supposed to do. It's supposed to show these solutions. So I'm going to point towards 5 and 10. On my number line, 5 and 10 are that way. So I'm going to point my arrow that way. And I'm going to make it nice and bold so that I know exactly which direction we're pointing in. So notice that my arrow pointed this way, even though my inequality pointed that way. So they're pointing different directions. So that's what I was telling you right here. Don't say, oh, the inequality goes this way, so the arrow must go that way. Not always true. Okay. Woohoo! There we go. If you'd like to pause the video and try C on your own, I would highly recommend that. Go for it. And then unpause it, and let's do it together. So, another number line. We're going to put 0 on it, and we're going to put the number we care about on it. Oh wait, 0 is the number we care about. Okay, then let's add a few other numbers. Let's add like -3 and 3. I don't know. Your favorite numbers. Put them on the number line. I just put them on there. If you just put 0, we don't totally know. Are your positive numbers over here and your negative numbers over here? Or are you switching them on us? We don't know. So you can't just put 0 on a number line. You want other numbers on your number line as well, so we know which side is positive and which side is negative. I know you normally always have positive on the right side, Sometimes we mix things up. I just want to know. I just want to make sure that we're on the same page. Okay, so now we know that 0 is the number we care about. Is that circle going to be open, or are we going to color it in, fill it in? Let's see, my symbol is greater than, which means I'm going to use an open circle. So I'm not coloring it in. Okay, and now x is greater than 0. So what is a number that is greater than 0? Well, 1 is bigger than 0. 2 is bigger than 0. 3 is bigger than 0. 18 is bigger than 0. Basically, any positive number is bigger than 0. So I'm going to point towards these numbers, which means I'm going to point this way. This way. So, were you correct? When you tried that problem yourself, were you correct? If you were, awesome job. And if not, remember that mistakes grow our brain. All right. So, let's move on. Oh, well, let's check our solution. Beautiful. Beautiful. Wonderful. Okay. And now, so we graphed inequalities. We had the inequality and we made a graph. Now we are given graphs and we need to write the inequalities. So what we're going to do is read the question. That is the first thing we're going to do. The graph shows the height restrictions, h, inches, for 2 rides at an amusement park. Write an inequality that represents the height restriction of each ride. Okay, so it's like, okay, you've seen these signs before, right? Wild Waves, other Seattle Center, back when that was a thing. You must be this tall to ride. The roller coaster, the bumper cars, whatever it is. So these graphs tell us how tall we can or can't be. So first, let's look at ride A. We're going to look at this graph. So h, let's see, and the number we care about, we can tell the number we care about is 48, because it has the circle with it. And now we are looking at numbers. Let's see, so the arrow is pointing towards 54, 52, and 50. All of these numbers are bigger than 48. So h must be bigger than 48. Now, don't forget that we need to look very closely at that circle. And that circle, whoops, that circle right here is closed. It's colored in, which means that this is greater than or equal to. So, you must be 48 inches exactly or bigger than 48 inches. You cannot be shorter than, what, 48 inches? There's 12 inches in a foot, so 48 inches divided by 12 is 4 feet. So you have to be at least 4 feet tall, exactly, to ride this ride. Wonderful. That is ride A. Let's look at ride B now. So let's look at this graph on the bottom. Okay, so h, again, we're using h just because they told us to. Write an inequality that represents the height restriction, and the height restriction is h. So we're just doing what the problem told us to. Okay, so we have h, and here the number we care about is 52. So now I'm going to look at, the arrow is pointing this way. It's pointing towards 50, 48, and 46. 50 is less than 52. 50 is smaller than. So we're going to have h is smaller than, or h is less than 52. Now, should I put a line under that? Is that less than or equal to, or is it just less than? Well, remember, if I look at the number I care about, that circle is open. So it means that I'm just going to have less than. No line underneath. Just less than. Okay. Woohoo! And there you have it. H is less than 52 inches. Cool. We have written, it said to write an inequality, and we wrote an inequality, so we are done with this problem. Let's see if we were right. H is greater than or equal to 48, and H is less than 52. Woohoo! We are correct. All right, so let's wrap it all up. Let's bring it all together in summary of what we have learned today. So here is the words. These are examples of different types of graphs and the different symbols that you might see. So actually here they have every single symbol. They have less than, and yeah, so they have less than, greater than, less than or equal to, or greater than or equal to. And we used the number 2 in each of these examples. And notice how the graphs are different. Less than typically points this way, greater than typically points this way. If your symbol does not have a line underneath, the circle is open. And if your symbol does have a line underneath, it is closed. So, yes, these are examples of graphs, algebra, and words for each symbol that we have in all of Chapter 2. These 4 symbols. Okay, if you want to put this in your notes, I'd recommend it. I'm not making you, because I think we've written down everything that you need. But if this helps you, you're like, oh snap, okay, I can connect the dots better with this picture. Great. Then write the picture down. Okay. So yeah, that is our lesson for today. Do you have questions? If you have any questions, please, please, please talk to your teacher, talk to a friend, rewatch this video. Remember, you can change the playback speed so you can watch this video at half the speed, so I'm not talking as fast. If you're like, goodness gracious, this woman needs to slow down, like, okay, slow down the playback speed. But remember that questions are good and they help you grow your brain. So please ask them. Here are some practice problems you can do if you would like to check your work on what you have learned in this video. Graph inequalities and write an inequality that represents the graph. But remember, those might be different than the problems your teacher has assigned. All right, and per the usual, we will end our video with a launch. This one comes from Deep Roy, and he says, inspiration comes from within yourself. One has to be positive. When you're positive, good things happen. So, the key here, or the main takeaway, is positivity. Your attitude is everything. I think I've said that before in some of these launches. Your attitude is everything. If you can have a positive attitude, life gets so much better. Just the other day, I had this like Starbucks cup that was a gift, and I dropped it. I think my husband dropped it, maybe. And it got scuffed up. It was pink and sparkly, and now it's been scuffed, so some of the like paint and the pink is gone, and the straw's a little bit dented and stuff. And I could have gone, honey, you broke my cup. Now it doesn't look as pretty anymore. That was my initial reaction, was no, it's not broken, but it's damaged. But instead, I made my attitude, you know, it's just a cup. And if I really want a perfect shiny one, I could get another one. It's just a cup. I had a positive attitude about it. Instead of being like, no, you broke my cup. It was like, it still works. It's not broken. I can still drink water out of it. So, it's good. It's all good. Your attitude is everything. When you're positive, good things happen. And it's not that more good things happen, but you just see things, like something that you might have seen as a bad thing, you now see as a good thing because of your attitude, because you're focusing on the positives in life. So, focus on the positive things in life. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.